This is How to Save Humanity in 17 Goals, a podcast brought to you by Nature Careers in partnership with Nature Water. I'm Fabio Pulizzi, Chief Editor at Nature Water. Welcome again to the series where we meet the scientists working towards the Sustainable Development Goals agreed by the United Nations and world leaders in 2015. For almost a decade, in a huge global effort, thousands of researchers have been using those targets to tackle the biggest problems that the planet faces today. In episode 9, we look at Sustainable Development Goal number 9, Infrastructure, Industrialization and Innovation, and meet an electrical engineer who sees efficient energy provision as central to a country meeting these aims.
I am Sinan Küfeoğlu. I am working as a Senior Policy Manager at the UK Office of Gas and Electricity Markets, OFGEM. Previously, I worked at Oxford, Cambridge, University College London, Aalto University in Finland on various energy economics and policy-related subjects. I'd like to clarify that the perspectives I express are my own as a researcher and do not necessarily represent or reflect the official or unofficial stances or views of OFGEM or the UK Civil Service. Goal number 9 is about building a resilient infrastructure and promoting sustainable industrialization and fostering innovation. So it has kind of 3 pillars: infrastructure, industrialization, and innovation. For the infrastructure in SDG number 9, the 3 main themes are to provide transportation, information and communication infrastructures. So these are the enablers for a sustainable development in industrialization and innovation. Without transport, without information and without communication, we can't enable economic activity, industry and innovation. So these are the main pillars picked up by the SDG number 9. I'm originally from Turkey. When I was a little child, Isaac Newton was my hero. That is why I was quite interested in physics. That was my favorite topic in the school. And when I started university in Ankara, in the Middle East Technical University, I wanted to study electrical engineering, just to continue all these, Faraday's works, Maxwell's work. I started being more and more interested in this electricity and energy fields. At the age of, I think, 14, I gave a seminar on the importance and future of nuclear energy to the city representatives, my city in Turkey. So I was quite interested and keen on energy-related subjects. That's why I studied electrical engineering in Turkey. Then I wanted to do research and get into academia. That is why I moved to Finland to do my master's and PhD, again in electrical engineering. But when I finished my PhD, I said, okay, this is a time for a bigger challenge to see, to be exposed to the outer world, because Finland is more of a reserved place, it's a happy country, yeah. Everyone, let's say in my university, Aalto University, we were all electrical engineers. Imagine a corridor. There are 40 people, they are all electrical engineers, and they look at the world from the same perspective, from the same window. So I wanted to change that, to expose myself for differences and different, problems, people's backgrounds. That's why I moved to UK, and in Cambridge I found exactly that sort of environment. For example, from this School of Electrical Engineering, I moved to business school in Cambridge. So in there I worked with business people, finance people, people from sciences, humanities backgrounds, any backgrounds. And I started working with companies, the industry, the public authorities, the companies from all around the world, and getting questions from them. A company approaches you, says that, okay, we have this problem. Can you do a research for us? I say, okay, yeah, we can do this. And we need these skills and experiences. They fund us. We go around our network, find the necessary skills. All together, a truly interdisciplinary research, we come up with answers. And when we publish our answers, in a short time period, we can see the real impact in the world. And that is what motivates me the most, to see the impact, what I do, what I publish in the end. After that, I experienced the same thing in Oxford. Now, with the World Bank in EBRD, now I'm with OFGEM, the civil service. We do regulations and policy making, and everything we do, whatever we change, immediately the next day there's a kind of impact in the orders of hundreds of millions, even billions of pounds. So this is quite, tempting and motivating. And energy is the enabler of everything. The biggest infrastructure challenge, I think, well, as a power engineer, I can say the access to electricity, the power network, because power network, in my opinion, is the biggest engineering achievement of humankind to this date, because it enables other sectors and other economies to continue. And 5-7 years ago in Cambridge, we published a paper on the future of power distribution in the world and investigated, what parts of the world has access to continuous power, what kind of networks they have. So around 1 billion people in the world right now lack continuous power access. And the concentration of these people are mainly in the global south. So there's an equality problem as well as technical problems of accessing electricity. So in my opinion, this is the biggest challenge, to provide electricity to everyone so that they will have an economy, they can create jobs and businesses, and they can sustain their modern social lives. Well, in addition to electric power, I can say access to clean water and sanitation is another infrastructure problem, because it is necessary to, as I said, sustain daily lives of dignified human beings. And again, this concentration of lacking access to clean water and sanitation is almost geographically the same with the lack of access to power. So these two are going, side by side, I think, in terms of challenges. So solving one will naturally solve the other, I guess, if the necessary actions are taken. As SDG number 9 reminds me of transportation, it says information and telecommunications. Well, transportation-wise, I think the world is at okayish levels, so we can connect and travel to even the remotest areas in the world. It is fine, I think. Information, well, it comes to telecommunications and internet. Yes, we should just distribute the internet to all regions in the world. Some companies, are doing some widespread big projects that promising that anyone on Earth can access the internet. I hope that will work out. In terms of telecommunications, 2G network is almost everywhere on Earth, but the adoption of 4G is lower and 5G is much lower. I'm sure those will increase in time as well as we achieve 2G. So, information and telecommunications are okayish in terms of when you compare with other problems in the infrastructure. When we talk about infrastructure, everyone thinks of investments, what will happen in the future, what we should do more to add on top of the existing one. But people tend to miss the thing that the existing infrastructure is aging as well. For example, in the energy network, the usual lifetime of equipment is around 50, 60 years, if we are lucky, 70, depending on the quality of the manufacturing. So replacing the existing infrastructure, the aging infrastructure, is another big challenge. I remember back in the day, we went to a factory in Turkey. I was in the university there, and they wanted to change the electricity infrastructure to a new one, to a smarter one, smart grid, smart energy systems. Yeah, popular ones, let's do that. So that was the year 2010. We went to that factory and I saw that the equipment were installed back in 1920s. They were German made, still working after 90 years, you see, but they had to be replaced maybe after 60 years. So they made it to 90 years. So these are huge costs, you see. In the developed world, well, the infrastructure is aging and it needs to be replaced. This is the biggest challenge. And the industry, it's transforming into, more digitalized, more green industries, more sustainable. Whereas in the developing countries, they still lack businesses, infrastructure. So basic infrastructure should go there first. I remember back in the day, we had a chat with a retired senior officer of one of the biggest oil companies in the world. I asked him a question, said that, he gave us a speech about sustainability. Imagine an oil company former CEO talking about sustainability. That's a bit ironic. I said, okay, you say we're going to create a sustainable world in the future. And I said, in that sustainable world, there is no place for you, oil companies. What are you going to do in terms of business? And he laughed a bit and said, I understand your enthusiasm, young man, but about 1 billion people lack energy right now in the world. And we are the first ones, the oil and gas companies, to reach these people before the electricity goes to them. So, the industrialization, the needs, they change widely between geographies. I think when we talk about the challenges, the solutions, we should address what we are talking about, where we are talking about. So the solution for this industrialization challenge, the practical and sensible solution would to provide decentralized and smart systems to the developing countries and least developed countries. For example, these solar systems, solar PV systems, together with energy storage assets and clean water and sanitation assets, they could be deployed so that these regions will have the sufficient amount of basic infrastructure to run their daily, errands. And this self-sufficient mini and micro infrastructure could be a solution in these underdeveloped regions, as long as financing mechanisms exist and provided to these regions. That's another problem, financing mechanisms. For the developed world, the challenge is digitalization and aging infrastructure. So in one hand, we're going to incorporate more digital solutions. In the other, we're going to green it by decarbonizing it. In the meantime, of course, we will replace the aging infrastructure with the new ones. We had this kind of a trend maybe 20 years ago saying that, okay, let's decentralize everything, our energy systems. Why not go for microgrids, mini-grids, self-sustaining cities, self-sustaining university campuses? Everything should be self-sufficient. Self-sufficient homes. These ideas emerged everywhere in the world. So we wanted to decentralize these power systems, for example. But after 20 years, 2 decades, when we see now that we are creating more bigger, gigantic, centralized entities rather than decentralization. For example, it happened in the UK. 20 years ago, we were talking about mini-grids, microgrids. Right now, we are creating this future energy system, future system operator. So it's going to be bigger, heavier in terms of physics, and more, authorities and technical capabilities will be concentrated on the centralized entity. So everything is going for centralized entities. So that's a kind of a big irony in the developed world, I think, that should be mentioned here. There are various innovation challenges. First, we can mention of this research and development expenditure. Again, there's this inequality in the developed world. A higher percentage of GDP is being spent for research and development, whereas in developing countries it's almost half of that, or maybe lower than half of that. Similarly, the number of researchers and academic activities in the developed world is much, much, much higher than the developing countries. So that means that the gap in between is going to get larger, bigger when time passes. So when we, announce this SDGs,